By now, you know that reinforcement learning is powerful. It is pushing the boundaries of what machines can do and is often outperforming humans in complex tasks like playing games or controlling robots. But you might still be wondering, how can I actually learn reinforcement learning? And can learning it be fun? Absolutely.
To find the entire detailed lesson with all the instructions, math, and code, visit our website edreate.com. There you can find everything you see here and much more. Plus, you can find the full code on github.com/edreate. So don't wait around and sign up now at edreate.com.
Reinforcement learning might be one of the most fun and engaging things you can learn in AI. Why? Because you get to teach agents to play games. This is how many breakthroughs in reinforcement learning have happened. Researchers design algorithms and train them to master games like Go, chess, and Dota 2. And not just play, but win, often defeating the best human players in the world. Here's the exciting part. You can do the same. The algorithms you will learn in this course are capable of playing games too. To keep things lightweight but still challenging, we will train an agent to land a rocket. Yes, seriously. We will use a library originally created by OpenAI and now maintained by the Farama Foundation called Gymnasium. It provides a wide range of environments, many already set up as reinforcement learning problems, where you can train and test your algorithms. From simple control tasks to complex simulations, Gymnasium brings reinforcement learning ideas to life. One of the environments we will focus on is Lunar Lander. It strikes the perfect balance, simple enough to grasp intuitively, yet complex enough to test and compare a variety of reinforcement learning algorithms. This makes it an ideal sandbox for learning, experimenting, and evaluating performance under different conditions. We will be working with Lunar Lander throughout the course. In the next section, we will define the problem more precisely, exploring its objectives, the challenges it presents, and the aspects of the system we can control. We will formally introduce Gymnasium and its usage in a later chapter. For now, just remember this. Reinforcement learning is about learning through experience, and the Lunar Lander is the perfect playground to begin that journey. The Lunar Lander Challenge. Imagine this. You're in control of a small rocket hovering just above the surface of the moon. Your mission is to land it safely and upright on a designated landing pad. Let's look at a quick animation to get a feel for the challenge, what the rocket is dealing with, and what tools it has at its disposal. Here's what's happening in the environment. Gravity is constantly pulling the rocket downward. It has side thrusters to steer and maintain balance. A main engine can be fired to slow down or control the descent. The terrain varies with each scenario, although the landing pad remains flat and centered. Without the right control strategy, things can go wrong quickly. The rocket might tip over and lose balance, crash into the surface, overshoot or undershoot the landing pad. So why is this problem hard? Because the rocket has to balance multiple objectives simultaneously, maintaining orientation, controlling speed, adjusting position, timing its moves precisely. Even small errors can lead to failure. To experience the challenge firsthand, I tried landing the rocket myself. The rocket starts from different initial positions in each episode, and the difficulty varies quite a bit. As you'll see, I didn't manage a single successful landing. My best attempt resulted in barely positive score, and the average across episodes was not exactly impressive. Now it's your turn. Try landing the rocket yourself using the Human Lunar Lander benchmark and see how your instincts stack up against the agent you'll soon be training. It's a great way to feel just how challenging this task really is. Core idea. If we try to write explicit rules for every possible situation the rocket might face, we quickly run into complexity. The problem space is too vast and dynamic to handle with traditional hard-coded logic. That's where reinforcement learning comes in. Instead of scripting every move, we let the rocket interact with its environment. It explores, makes mistakes, receives feedback, and learns from the consequences of its actions. There are no instructions. No one tells it exactly what to do. It learns to land safely through experience, by trial and error, guided by rewards. This is the essence of reinforcement learning, and this is exactly how we'll teach the rocket to land. Reinforcement learning to land the rocket. We will train a reinforcement learning agent to solve the Lunar Lander problem. In the beginning, the agent will crash a lot. But with each failed attempt, it will observe what went wrong, receive feedback through rewards and penalties, learn which actions lead to better outcomes. Over time, the agent will improve. It will learn to land smoothly, precisely, and reliably, even when the conditions vary from episode to episode. After training, your agent will be able to land the Lunar Lander with remarkable precision. You will see a dramatic difference in performance in the before and after video below. Pretty amazing, right? What you'll achieve. By the end of this course, you will be able to train your own agents to land the rocket. You will understand the key elements of the learning process, implement several reinforcement learning algorithms, experiment with your models, tweak them, and improve performance. Watch your agents go from crashing to landing successfully. We are almost ready to jump into the action. In the next chapter, we will build a deeper understanding of the core building blocks of reinforcement learning: agents, rewards, actions, states, policies, and more. Let's get ready to land.